Hey programmers, Alvin here. Welcome back to our series on linked lists, and this time around I want to teach you about linked list deletion. We've talked a lot about some different linked list methods, but we actually did not cover how we can delete a given node from a linked list, and so we'll go through it today. And I really think that this operation deserves its own video because it actually exposes us to a pretty cool pattern that we can use in other linked list problems. So let's start to formalize what our goal is for this problem. So here's a little prompt. What I want to do is write a function called delete value that takes in the head of a linked list and also some target value. What my function should do is delete the node of the linked list that contains the given value. My function should also return the head of the linked list. Now give us a nice little constraint here. We can always assume that the linked list contains unique values, which means we would only ever be deleting a single node from the linked list. A few things I want to point out about this prompt is we're going to be given the head of a linked list, so really just a node as an argument. And along with that, by the time we're done with our function, we need to return the head of the linked list. And depending on which node we delete, the head could be different, right? Imagine that I happen to delete the first node, or rather the head of my linked list. That means the second node would become the new head. So we're going to have to watch out for that edge scenario probably. So before we just jump into the code implementation of this one, why don't we sketch out some ideas to set us on the right path. So here I have an example of a linked list that contains 4 nodes A, B, C, D. Let's say for argument's sake, our goal was to delete the C node over here, right? So I want to remove this node from my linked list. And what should happen is my resulting linked list should just have the values A, B, D. If I kind of remember the prompt, I'm going to be given access to the head of the initial linked list. I have to watch out for that, which means that I actually do have a way to eventually target this C node, right? I can just travel through this linked list until I hit this C node. However, we have to be aware of the fact that we're given a singly linked list, right? So let's say that I traversed to my C node over here. Well, that actually wouldn't be good enough because when it comes to deleting C and like excluding it from the linked list, I actually need to reroute B's pointer, right? I need to take this pointer over here. Instead of B pointing to C, it should be rerouted and point directly to D, right? And at this point, if I were to traverse from the head of my linked list all the way through the end of it, I would just hit A, B, and D, and then my linked list would end and be over, right? So the pattern that I need to recognize here is when it comes to deleting the C node of this linked list, I technically need access to its previous node. So I'm going to have to come up with a strategy to kind of do that, right? Because when it comes to editing the nodes, to delete C, we really have to change B's next pointer, right? Because it's a singly linked list. So now that I have that big picture idea in mind, let's begin to sketch out a real strategy that we can use and actually translate into some code, right? So let's say right now my target to delete, like we said before, is just going to be the value C. So I want to remove that C node. So I'll just keep that in mind. So if we consider some linked list patterns, the most common one we've been using in the past has us create some current pointer in which we use to traverse through the entire linked list, right? By setting current equal to current.next. So let's say I chose that strategy over here, right? So I'm going to denote my current, I'll just call it CUR. So let's say I begin my cur pointer pointing at the head of the linked list, right? So it's pointing to A. I know in the long run, I'm also going to need access to not only some node, but its previous. So I think the clever thing to do here is to also begin another pointer, which I'll have to initialize as maybe something like null, right? So I'll have some previous pointer. I'll just kind of denote it over here because technically A doesn't really have a previous, right? So when I initialize this variable in my code, I'm probably going to set it equal to null, right? But here's what I should do. Now that I have my pointer for cur pointing at A, I can check, does current's value equal my target? That is A equal to C? It's not, so A is not the node I need to delete, right? So I need to keep going. So what I can do is just reassign these pointers, right? I already know that cur will become cur next, right? So I'm gonna move my cur over here. And then I'll also shift previous along the way. So what I'll do is I'll drop these pointers and then I'll reassign them. So cur now moves over here, and previous can now reference what cur was previously, right? And at any point in time, the value that I'm checking is for cur, right? I don't really care about the value within previous. This previous pointer is only going to be useful when I need to do the deletion, right? So now current is pointing at B. I check, is B equal to C? It's not, so I can keep going because B is not the node I need to delete. So I'm going to shift both of these pointers over by one space. And now things get interesting, right? My cur is pointing at this C node, and I check, is C equal to C? That is my current node's value equal to my target value? And that's true, right? So this node is where I need to do my deletion. But to actually perform this deletion, I must take this previous node and make some edits to it. In particular, now that I have a reference to the previous node, I can take previous and set its next to just be current's next, right? So I can kind of kill this next pointer over here and reroute it pointing to D over here, right? But the key idea here is that I'm going to need access to not only the current node to check that I'm deleting the correct node, but I'm also going to need a previous pointer to actually perform that actual deletion, right? So once B's next pointer is set to D, it's actually the case that the C node would be deleted because it's actually inaccessible in memory, right? There's nothing that can reference the C node, so it would be garbage collected in our program. And of course, all of that would result in a linked list that doesn't contain C at all, right? So just A, B, D. All right, so I have a pretty good idea of how I want to actually solve this algorithm. Let's begin to translate these ideas into some code. So here I am in my code editor where I just have some initial code. So this stuff should look pretty familiar. I just have a classic node class. So this node class is going to be used to build up a linked list. And in the interest of time, what I have here are just some instances of nodes created, right? So I don't have some large like linked list class containing all of the methods. Instead, I just create some instances of nodes, and then I just create the connections between those nodes, right? By just setting A's next to B, B's next to C, and C's next to D, right? Performing this operation would kind of give me a linked list with this shape, exactly like my example from before. I have A, B, C, D. And here I want to write a function called delete value, which again takes in the head of the linked list, so it takes in the A node. I can pass in some value, which it should hopefully delete, right? So after I call delete value, the linked list should now have A, B, D. Notice that the C node is missing over here. So this is actually a pretty common pattern when it comes to how you might be given some linked list problems, right? They're going to have you write a function that takes in the head of a linked list, and they would have already set up the linked list for you. But let's begin by actually writing this function. So I'm going to define my delete value function. So this function needs to take in the head of the linked list and also my target value. And let me start by creating some running pointers to use, right? So I'm going to use my current pattern, right? So I'll say cur, initialize to head. And something that was present in my diagram was I also need a separate pointer to kind of refer to the previous thing. And when I initialize this previous pointer at the start, because current's equal to head, there's nothing before the head. So I'll just initialize previous to like null, let's say. You could probably also leave it as undefined, but I'm just going to set it equal to null over here. Cool. So at this point, what I'm going to need is some baseline code that just, moves current all the way through the linked list, right? So I know that that's a pattern we've coded a lot already in previous episodes. So I'll just bang it out over here. I always want to start by implementing code that's familiar to me, right? So I'm going to keep iterating a while current is not equal to null. So basically that refers to, hey, keep looping until you hit the end of the linked list, right? Cool. So to finish this pattern, to keep progressing my current pointer, I can set cur equal to cur.next for now. So I want to be testing my code as I go. I'm not going to utilize this previous variable right now. I'm not even going to do any deletion. For now, why don't I just console.log my current.value, right? I love to test my code as I go. So why don't we give this code a shot? This should just print out my original linked list, so A, B, C, D. And it should be all on new line, so I'll run my linked list file. So yeah, it looks like my while loop is working fine, right? So I'm able to just sift through every node in order of my linked list. But now let's start being particular with what we do with our previous variable over here. So I'm going to drop this console.log. Looks like that logic is working. And how do I want to set things over here? Well, I know that as I iterate through every node of my linked list, I need to check if my current node's value is the same as my target value. So I'm going to express that over here, right? So if current is equal to my target, or really I should be saying if current's value, right? Because cur is a node, right? That has a val property, right? So if my current node's value is my target, then I need to delete it, right? I need to delete that node. So let me think about what that means, right? So I know that I'm not setting previous like over time in my while loop, but let's say previous was what it should be, right? So it should always point to the previous node. If I need to delete the current node, then it should be as simple as setting previous.next equal to current.next. Right, remember what we did in the diagram, right? If I need to delete C is my current, that means previous is B. To kind of complete this deletion, I change my previous next, I changed B's next to D, right? So this should do the deletion over here. Now I have to worry about how I should be updating my previous. So that's going to be a little tricky. So on every iteration of this while loop, how should I be updating previous? Well, I'm just kind of shifting my window of 2 nodes at a time. So my previous should just become my current. Cool, and then of course, cur could just become cur.next, right? So kind of the pattern you should have in mind is if I'm tracing through this little linked list at the bottom again, I'll use C and P to represent current and previous. So let's say that previous is this A node and then current is pointing at this B node, right? If I run this logic, then what happens? Well, I set P to be the current, so it goes over here, and then current equals current.next. So current shifts to the next node over here, and this is exactly the logic I want, right? I just want to have the sliding window of just 2 nodes. Cool, so that code looks pretty good. Let's try to run this code, and then I also need a method to probably print out my linked list, because I really want to make sure that this code actually works, right? So I'm wondering if I get any like runtime errors here. So I don't get any errors, and I want to start visualizing things properly. So why don't I create a quick little function that just prints out all of the values in the linked list. We kind of just wrote it earlier. Maybe for fun, I'll do this recursively because it's really quick. So I'll say print. It takes in some head of a linked list, and I'll write my base case, right? If my head is null, that means I'm either at the end of my linked list or it's an empty linked list. I'll just return. But in the recursive scenario, what I'll do is I'll console.log this node's value. And besides that, I need to print out the rest of the nodes in the linked list, so which means I should call print on head.next. Cool. So for fun, after we call delete on our A node, which is like the head of the linked list, I need to actually call print on that A node, right? So when I call print, maybe I'll actually call print before and after, right? So let me see what I get over here. Cool, so if I scroll to the top of my output, so it looks like before I do my deletion, my node values are A, B, C, D. And just to be extra sure of that, let me just put a little dash over here. Yeah, at the start of my code, my linked list contains A, B, C, D. After I run my deletion, it just contains A, B, D, right? So it looks like we properly deleted that C node in my linked list. So that wasn't too hard, although we definitely want to fix some details here to make sure that this code really meets the specification, right? So something they mentioned in the prompt was our delete value function should return the head of the linked list. So let's say after the while loop, after all is done, let me just return the head of the linked list. And the reason that they want us to return the head is actually pretty interesting, and it's an edge case we actually haven't covered yet. So let me make sure that my delete value is returning the head properly. So that means I should be able to do something like this. I should call delete value on line 43, and I can save like the new head in some variable. Then I should be able to just call print on that new head node. Obviously, in this particular test case, the head node stays as A, right? But I want to make sure that I'm returning that node from delete value. So if I run this code, hope that it works. So it looks like my function is able to return the head node properly, but let's work on some edge cases, right? That's really why they want our function to return the head over time. So when it comes to like linked lists, edge cases that we should be aware of and we should really test for correctness are things like maybe deleting the first node of the linked list, as well as deleting the last node, right? So let's start by testing my code if it deletes the last node, right? So the last node is D initially. So I want to check, can my code delete the D node? Let's give that a go. Cool, so it looks like it works, right? My initial list has ABCD, my final list has ABC, so I did delete the D node. But now we need to also satisfy the scenario if we delete the very first node, which I don't think our code actually covers right now. So let's run this, right? So my initial linked list is ABCD. My output now should just be BCD. So let's try that. Yeah, and here I get, again, error, right? So definitely something went wrong within the scope of our delete value. So let's analyze that line of code. It's complaining about line 24, which is right here. This is actually a pretty straightforward one to reason out why it doesn't work, right? So let's say that we're trying to delete the A node, right? So I know that cur is pointing to the A node and previous is set to null, right? So I check, is my A node not equal to null? That's true, so I can run the code inside of this first iteration. So I jump to my if statement. Is current.value, which is A, right? Is A equal to my target? And that's true, right? A is the node I'm trying to delete. And what I try to do is set previous.next equal to A's next. So I'm trying to set previous.next equal to B, right? To the B node. But if previous is null, then I can't set null.next, right? So this is going to be a special edge case we kind of have to handle explicitly in our code, right? So I think the cleanest way I would handle this edge case is really just having an if statement at the top, right? So I'll just go ahead and check, hey, if you're asking me to delete the very first node or the head of the linked list, then the deletion is as simple as me returning head.next, right? That means you're trimming out the head out of your linked list. Cool, so this code looks pretty good, and it should handle that explicitly. So if I run this code now, with that small change, I should be getting a BCD in my output, right? And there it is. Awesome, so there's a nice iterative solution to delete value. So let this marinate for a bit. Key things I want to emphasize about this solution is it's fairly similar to some previous linked list algorithms we wrote previously, things like just printing out values in a linked list, as well as things like inserting a node into a linked list, right? The only way that this solution is kind of different from our previous code is that now I have two pointers which I need to keep up to date together, right? So over time on every iteration, not only do I set cur equal to current.next, but I maintain a reference to the previous by just setting previous equal to the cur, right? Because I'm kind of moving that sliding window down the entire linked list. While we're here, let's go ahead and discuss the efficiency of this code, right? So for this iterative delete value solution, let's talk about the time complexity. So time complexity is pretty straightforward. It seems to come mostly from this while loop, which in the worst case would have to iterate through the entire linked list, right? So if n is the number of nodes in my linked list, I think in the worst case, they give us a target that actually is not present in the linked list, which means our while loop would have to make exactly n iterations, right? So our time complexity is O of n, where n is the number of nodes in the linked list. And our space complexity over here is actually O of 1 in terms of space, right? So I have O of n time and O of 1 space. Here I'll argue that the space is O of 1 constant because I create a fixed number of variables. I don't create any arrays, and I actually perform this deletion in place, right? It's not like I'm creating a new linked list that is missing my target node. Instead, I'm modifying the existing linked list, right? So this is actually the most efficient we can ever do for this delete value function. So that was our iterative solution to the deletion function. And I also want to show you how to implement a recursive solution for the culture of it, right? So let's start by defining our delete value once again. And here the constraint is to do this recursively. But the nice thing about implementing things iteratively and recursively is it's basically the same strategy, right? The important thing that I have to do when I translate some like iterative code into recursive code is instead of a while loop with many iterations, I write some recursive code with many recursive calls, right? But the logic's pretty much going to be the same, right? So in terms of like the signature of this function, I think I'm going to kind of split this up into two functions just so I can make sure that the top level call to delete value is exactly what they asked for, right? So they just want to take in a head node as well as some target node. So I'm going to change this back to C for a moment. And so I'll take in my head and also the target. But I also want this to be recursive, and I know I'm going to need some extra arguments for this. So I'm going to create an underscore delete value method, which I think will still take in the head and the target and probably some other arguments in a little bit, right? So let's start to frame this strategy through some recursion, right? So I think instead of head, maybe to make it speak more closely to our iterative code, maybe this will be a little more clear for all of you, I'll set this as cur, right? So I'm going to refer to this as cur. And I know that I also need access to the previous, which is pretty easy to do. So what I'll do is also take in some previous pointer over here. right? So I guess the two variables that I created in my iterative version kind of translate into some different arguments in my recursive version, right? So now I just have to figure out how I can actually pass in updated values for current previous. It's basically going to be the same code over here, right? So I think translating this code is pretty straightforward. Let me just start with maybe my recursive scenario. I think that's actually very easy to identify, right? To take this code and translate it, my recursive scenario would just mean calling the same function again and shifting my values for previous and current, right? So I know that in my next call, my current node needs to become current.next. So over here, I'll pass in current.next, right? And my previous node actually becomes the current. So don't get too tripped up over here. Remember that arguments are passed in positionally, right? So whenever someone calls my delete value function, the first argument is current, the second argument is previous, right? So that means that when I make this recursive call, cur.next becomes the new current, and then cur becomes the new previous, right? I'm kind of shifting that window over to the right by one space. So this code is looking pretty good. Now I need to worry about like my base case scenario. So there are a few base cases that we should have in mind over here. I think maybe the first one we should do is if we find the thing we need to delete, right? So how can I start to translate this code into some recursive code? So I'm still going to use an if statement here, I think. I'm going to check, hey, if my current value is equal to my target, then I must do the deletion, right? Then I'll say delete cur. So how can I actually express that in some JavaScript code, right? So delete cur, that's just a matter of rerouting my previous next kind of over the current one, right? So just like we did over here, I think it's as explicit as just saying, hey, say your previous.next equal to your current.next. Remember that this line of code, line 44, that means that we are now excluding cur itself from the linked list chain, right? So that code looks pretty good, right? And then along with that, how can I have this code properly return some nice values, right? So maybe one thing I also want to add is like maybe the target does not exist inside of the linked list. I guess that means there's nothing to delete. So I'll just go ahead and check, hey, if your cur is equal to null, that means you went too far and you didn't find the target, so you can just return, right? There's nothing else to do over here. And in terms of these two base cases, right? This base case is saying, hey, we're done with the deletion, so I need to return. And then this base case over here refers to, hey, we actually did not find the target node at all within the linked list, right? If this if statement on line 47 is true, that means I exhausted the entire linked list and did not find my target. When it comes to like multiple base cases, always think about the order of these base cases. So actually the correct order here would be putting this one at the tippy top. And why is that, right? In the scenario where cur is indeed null, if you did this line, you'd say null.value, that would give you an error, right? So preemptively, you need to check if cur is empty or null first before you try to access any properties like .value. Cool, so I prefer the code like this. And at this point, yeah, let's start to kind of chain things together with our main function over here. So I know I definitely need to call this recursive underscore delete value function, and I'll set up those initial arguments. So of course, my current begins as my head. How does that get translated? Well, it was exactly over here. And then the previous argument I pass in should just be null initially, right? Because there is no previous when I start my traversal. And I also need to pass in the same old target. Cool, so that should be my initial call to my recursive function. And I know that my delete value needs to still return the head of the linked list. So I'll just return the head over here. So that top level call looks good to my recursive delete value function. But I also notice now that I didn't pass in the target over here. So let me go ahead and add that in, right? The target never changes over time. But at this point, I think we're ready to test our code. Obviously, we're not handling the edge case where we need to delete the head or the very first node of our linked list. But I think this code is at least good enough to test if we want to delete a node somewhere in the middle of our linked list like C, right? So if this recursive code works, I should get the output of ABD, right? Because we're deleting the C node. Let's give it a shot. Cool, right? So our initial linked list has ABCD, and our new linked list has ABD, right? So it looks like we did properly delete that C node. But now let's go ahead and fix the edge case where we need to delete the very, very front of the linked list, which I believe still needs to be a nice explicit if statement, right? So let's say maybe in our main function over here, if you wanted me to delete the head, so if head's value is the same as your target, that means you want me to delete it, so I can just go ahead and return to you the thing right after the next, right? Remember that your delete value function, like it said in the initial problem, needs to return like the new head of the linked list potentially. So let's go ahead and try to delete A. So now my output should just be BCD. Awesome, there it is. And for completeness, let's go ahead and delete just the end of the linked list. So I'm going to delete D now, which means my output is just ABC. Nice, and there we see our ABC. Cool. So that was a nice recursive implementation of delete value. Again, to me, the strategy is basically the same. I'm still using 2 pointers as a sliding window through my entire linked list. But I did this recursively, right? So whichever you prefer, I think they're both great solutions, but you do need to be aware of the efficiencies of this recursive algorithm, right? So in terms of the time complexity, it's still going to be O of n time, or n is the number of nodes, because I'm going to make n recursive calls, right? In the worst case, I have to travel all the way through my entire linked list. But in terms of the space complexity, it actually is more costly with the space. It is going to be O of n space because we're going to have to use n stack frames, right? Because I'm solving this recursively, I must consider how many stack frames I put on the call stack before I bottom out at my base case, right? So in the worst case scenario, if I need to make a recursive call for every node of the linked list, that would mean n calls on my call stack, right? So O of n time, O of n space. So overall, if you compare our two solutions, I would say that the iterative version is slightly more efficient in terms of the space, right? It's O of 1 space. So if that's important to you, then I guess prefer the iterative solution over here. So there you have it. Together we explored how to delete a node out of a linked list, and we also studied how to do it iteratively as well as recursively. So key thing I want you to take away from this lesson is how we utilize the 2-pointer strategy, right? So in this one, we use 2 pointers, one for the current node, as well as one for the previous node. And that gave us a means for actually performing the deletion, right? In a more broader sense, not just for deletion, the double pointer strategy is going to be pretty useful. I will actually utilize it again in the next video. So stay tuned for that.